2.3.2 Resource Scheduling and Optimizational Learning Objectives. This section considers the time schedule, and considers techniques used to develop and present schedules that show when work within a project is planned to be performed. A project schedule can reside within a program or portfolio schedule, and have dependencies on the completion of other projects. By the time you have studied this section, you will have completed the following: Learning Outcome Assessment Criteria. 6. Understand resource scheduling and optimization in a project. 6.1 State the purpose of scheduling. 6.2 State the purpose of critical path analysis. 6.3 State the purpose of milestones. 6.4 Define the term time boxing. 6.5 Outline options for resource optimization, including resource leveling and resource smoothing. 6.6 Define the term procurement strategy. Know the purpose of scheduling. A schedule is a timetable showing the forecast duration and the start and finish dates for activities or events within a project. Start and finish dates can be calculated with regard to available resources and external constraints as well as project logic. Once established, the schedule will be used throughout the project to update progress, forecast performance, and communicate this information to stakeholders. Since show team members when tasks are due to be completed and the overall project duration. Since show key milestones and progress towards achievement of these. When work starts within a large project, there can be a number of individual schedules to deal with different aspects of the project. The master schedule combines coordinates and keeps track of all subordinate schedules within the overall project scope. The purpose of critical path analysis. Critical path analysis uses a scheduling technique to predict project duration by analyzing which sequence of activities has the least amount of scheduling flexibility and is, therefore, critical if the planned overall duration is to be achieved. The critical path shows the sequence of these activities through a precedence network from start to finish, the sum of whose durations determines the overall duration. Prior to any analysis being conducted, a project network is created from the agreed work packages and activities defined in the work breakdown structure, as shown in Figure 2.3.2.1. The dependencies exist because of the logical relationship between the activities dictated by the technical characteristics of each activity. In simple terms, the kettle can't be boiled until it is filled with water. Boiling the kettle is dependent on it being filled with water. Filling is a predecessor of boiling. The logical relationships between those two activities have now been established. Those who have the technical expertise, and may also be delivering the work, will collaborate to agree what the logical sequence of activities should be, ensuring that this is optimized as much as possible to be the most efficient way of delivering all the activities. Figure 2.3.2.1 Network created from work breakdown structure. Establishing the logic between the activities enables a precedence network to be determined that shows the relationship between activities. There are some common dependencies that are used when creating networks, as shown in Figure 2.3.2.2. Figure 2.3.2.2 Common dependency types. The most common dependency is finished to start, and this acts as a default choice until sufficient information is known about the individual activities to consider an alternative. Once the network has been created, then estimates of duration based on the effort required can be made. The resulting critical path can be identified as the longest pathway of activity, as seen in Figure 2.3.2.3. Figure 2.3.2.3 Network showing activity durations and critical path. Figure 2.3.2.3 shows the critical path as activities A, B, F. Other pathways are shorter in their duration, and are said to have float. The critical path also represents the shortest time to complete all activities in the logical order required. Float is a term used to describe the flexibility with which an activity may be rescheduled. Float is created when a shorter duration activity is in parallel with a longer duration activity in the network. For example, if a 10-day activity was in parallel with an 8-day activity in the network, the 8-day activity would have 2 days float. This means that it could be moved, extended, delayed, or split by up to 2 days without affecting the overall duration of the project. It is useful to identify float, and it is mainly used to help schedule activities within resource constraints. There are various types of float, such as total float and free float. Total float is defined as the time by which an activity may be delayed or extended without affecting the overall duration, or violating a target finish date. Free float is defined as the time by which an activity may be delayed or extended without affecting the start of any succeeding activity. The purpose of milestones. A milestone is defined as a key event selected for its importance in the schedule, commonly associated with tangible acceptance of deliverables. It is good practice to produce a milestone schedule, to show stakeholders the major milestones and for reporting current and forecast progress. Once the network analysis has been completed, and the network-optimized Gantt chart is created to show the activities against a timeline, see Figure 2.3.2.4. Milestones are entered into the schedule as if they were an activity, but they have zero duration and therefore act as markers, rather than having any duration in the timeline. In this simple example, the milestones are shown as black diamond shapes, and so they are easy to see within the detail of the bar chart. However, if this was a more complex schedule with many more activities, the milestones may not be as visible. Figure 2.3.2.4 Network and Gantt chart showing milestones. There are a number of stakeholders, such as the sponsor or senior management, who do not need to know the detail of specific tasks, floats and dependencies, etc. They do, however, need a high-level summary of current progress. A milestone chart will provide the necessary level of communication. The milestone chart will show a stripped-down version of the schedule with activity bars removed, as shown in Figure 2.3.2.5. This example timeline in weeks shows the project milestones at a reference time now. From this chart it can be seen that the project has started on time. However, it is forecast that milestone MS1 is to be achieved 2 weeks later than planned. The delay in reaching MS1 seems to be causing a forecast delay on MS2 of 4 weeks and a delay of the finish milestone of 3 weeks. Hopefully the early warning created by the forecast will prompt action to be taken that might reduce the slippage. Figure 2.3.2.5 Milestone chart. The term time boxing. Many agile methods apply the idea of time boxing, where an iterative life cycle is adopted that seeks to deliver value in an incremental way, rather than adopting a linear or waterfall life cycle, which aims to deliver value at the end of the project. A time box is an iteration with a fixed end date that is not allowed to change, thereby adjusting the scope and quality to deliver on time and to cost. The agile approach will commit to delivering on time, and so each iteration may have several time boxes. Multiple time box iterations are likely to be employed in parallel to develop different aspects of the deliverable. Having such a rigid approach to time planning maintains the team's focus on achieving targeted goals. Overall, using iterations allows earlier return on some of the benefits that have already been implemented while validating the concepts and engaging users. Options for resource optimization including resource leveling and resource smoothing. The main objective of resource optimization is to make sure that all resources are used optimally. There are several stages to building up a clear picture of how the resources will be used to deliver the required scope. The first stage is to allocate suitable resources to each of the tasks. Checks will ensure that they have the right skills and competencies to do the assigned work. Once resource allocation is complete, the resource demand profile can be viewed using a resource histogram, a block graph showing the quantity of resource that has been allocated over the time schedule, as shown in Figure 2.3.2.6. Figure 2.3.2.6 Resource histogram showing the demand profile resulting from resource allocation decisions. Figure 2.3.2.6 shows that the work can't be done as scheduled as the current availability of resource is limited to 4 and the allocation to activity exceeds that limit. There are 2 basic options available to the project manager: resource leveling and resource smoothing. Resource leveling, resource limited scheduling, answers the question, with the resources available, when will the work be finished? Leveling is used where resource availability is limited, for example, specialists or complex testing equipment, or where there might be space or accommodation restrictions. Resource leveling can be achieved in the project by sense redefining the scope of the activities to be undertaken by the particular resource concerned. In simple terms, this might mean giving some of the work to an underutilized resource. Sense redefining the specification, avoiding, if possible, any compromise to the quality of the final product. Increasing task duration to reduce the overall resource requirements. Sense increasing resources on earlier tasks to bring workload forward, such that peaks in the future are reduced. This will have cost, and possibly quality, implications. Sense moving activities that are not on the critical path, to reduce demand at peak times, i.e. using free and total flow to optimize the schedule. Figure 2.3.2.7 shows the result of resource leveling, where activity F has been extended by removing one resource, and spreading the activity over an additional 2 time periods. The activity has been extended within its available float, so will not have any effect on the overall duration. For this to be possible in practice, it assumes that the activity will behave in the desired manner. It may not be realistic to think that an activity duration will expand or contract in exact proportion to the people being added or removed. Prior to making effective resource optimization decisions, a thorough examination of the task and its technical characteristics would be necessary. Figure 2.3.2.7 Resource histogram. After leveling, when all leveling options have been considered and a solution is still unavailable, the project duration will extend, but hopefully this will be minimized as much as possible. Resource smoothing. Time-limited scheduling is used when time is more important than cost. The objective is to deliver the work within the fixed time scale. This may involve reducing the duration of activities by adding resources, for example, more people, the same number of people working longer hours, or additional equipment, and then trying to get a smooth usage of resources, avoiding peaks and troughs of resource demand, and optimizing the flow of resources from one piece of work to another. Resource smoothing needs to be considered on a resource-by-resource basis, particularly when a reduction in the overall duration of the schedule is required, perhaps in response to changing time priorities. Applying additional resources to critical path activities is the only way the overall schedule will be impacted. If additional resources were to be applied to activities with float, it would just provide additional float to those activities, with no impact on the duration overall. Resource smoothing will ensure that any peaks and troughs will be smoothed out when additional resources are being applied. Achieving a smoothed resource profile may require some redefinition of the order of some of the work, where the logic used originally was discretionary, not mandatory, for example, where work could be done in parallel rather than in sequence. Achieving the optimally resourced schedule can be a creative process requiring multiple iterations to get the best result possible. There is, of course, a finite limit to the resource that can be put into some tasks due to the nature of the task and the environment. For example, a task involving data entry will be impacted very little by additional resource, if there is only one data terminal available. If resource really is finite, there are no more hours available from skilled people or no more equipment is available, then there is no option but to extend durations and the overall project time to accommodate this, as shown in Figure 2.3.2.8. Figure 2.3.2.8 Resource leveling and smoothing options. The term procurement strategy. The procurement strategy is the high-level approach for securing the goods and services required from external suppliers to satisfy project, program and portfolio needs. External suppliers will often be contractor organizations, but may also be another department or division of the host organization. Where the external source is a separate legal entity, the terms under which goods and services are procured will be the subject of a legal contract, which will outline the legally binding obligations between the various parties. When the supply source is part of the same organization, an internal or service level agreement may be used. Decisions to make with the sponsor in wider governance are: sense how much risk to retain in the project and how much to share with suppliers in the supply chain. sets on a continuum from transactional based solely on price and supply to collaborative, considering a more integrated relationship and working together to serve parties' interests. What type of relationship is desired with different suppliers, and why? The complexity of the work, the capability of the team, the client owner's appetite for risk, and the analysis of the market are all considered prior to deciding what procurement route is best. The resulting procurement strategy for the project considers make or buy decision, do the work in-house or procure external contractor supplier selection, objective selection following required process, sense contractual relationship, type of contract for required work with suitable terms and conditions, sense reimbursement methods. On what basis will suppliers be paid, fixed sum, variable, milestone payment, sense contract administration, managing service delivery and ensuring contractual performance. Standalone projects may be able to take advantage of procurement arrangements set up by the host organization. Similarly, those that are part of a program may find that much of the procurement is handled at the higher level. Delivery contractors often have to use their client's procurement process and choice of supplier as part of the conditions of contract. When a project has specialist or unique requirements, it will need access to procurement specialists, and must consider procurement implications as early in the life cycle as is practicable. Waiting until the full approval of the project at the end of the definition phase may, for example, result in tender delays and long lead times, having a detrimental effect on the schedule. In some projects, procured resources can represent the majority of the cost, so rigorous procurement process is vital to success. It is common for organizations to hold approved supplier listings and carry out periodic audits to provide assurance of quality, capability, and capacity to deliver. All procurement involves risk, and all aspects of the resource management plan must be prepared with risk management in mind.